Hello friends, welcome to Secret of Electronics. In this video, we will learn how to make a automatic water pump controller with a latch system using a 5-5 timer IC for a water tank. In this circuit, you can see a transformer. This transformer converts AC 220 volt into AC 12 volt. After this, you can see 4 1 and 4007 diodes. These diodes act as a bridge rectifier, and this bridge rectifier converts AC 12 volt into DC 12 volt. After this, 2200 microfarad capacitor filters this DC voltage to smooth it. After this, you can see some resistors and capacitors are connected to the 5-5 timer IC. You can also see levels like on, off and plus 12 volt. We will place the plus 12 volt wire or level at the bottom of the water tank. The on wire or level will be placed in the middle of the water tank. Above the plus 12 volt wire or level. Finally, we will place the off wire at the top of the water tank. Let's consider the scenario where we set up this project with the water tank and pump, and the water tank is empty. In this case, the 5-5 timer IC will provide plus 12 volt at the output. As a result, the IRF44 and N-channel MOSFET will turn on, because as we know, applying a positive voltage at the gate terminal of the N-channel MOSFET causes it to turn on. Consequently, the relay will also turn on, activating the water pump since the pump is connected in series with the normally open and common terminals of the relay and a AC 220 volt power source. The on LED will also light up to indicate that the water pump is on, as this LED is connected in parallel with the relay. The 5-5 timer IC will provide plus 12 volt at the output until the water level in the water tank reaches the off wire or level. As a result, the water pump will remain on until the water level reaches the off wire or level in the water tank. When the water level in the water tank reaches the off wire, then the 5-5 timer IC will change its output to negative or 0 volt. This will cause the N channel MOSFET to turn off, and the water pump will also turn off. The on LED will turn off as well. At this point, the off LED will turn on to indicate that the water pump is off. As the off LED is connected to the IRF9540 and P-channel MOSFET, we know that when a negative voltage is applied to the gate terminal of a P-channel MOSFET, then it turns on. Now when the water level in the water tank drops below the on wire, then the 5-5 timer IC will change its output to plus 12 volt, causing the water pump to turn on. The water pump will remain on until the water level in the water tank reaches the off wire. When the water level in the water tank reaches the off wire, then the water pump will turn off. I have created a PCB according to the circuit diagram. Now let's test this PCB by connecting it to the power source. I am using a AC 220 volt lamp in place of the water pump because the water pump is not available. Now you can see the lamp is on, meaning the water pump will also turn on, and you can see the water pump on LED is also light up. Now I am filling the water glass with the water. You can see that when the water reaches the off wire, then the lamp turns off, meaning the water pump will also turn off, and the water pump off LED will turn on to indicate the water pump is off. Now I am dropping the water level in the water glass. You can see that when the water level in the water glass drops to the on wire, then the lamp turns on, meaning the water pump will also turn on, and the pump on LED will light up to indicate the water pump is on. Now you can see the lamp remains on until the water level reaches the off wire. When the water level reaches the off wire, then you can see the lamp turn off. If you like this video, do not forget to subscribe to our YouTube channel to watch our upcoming interesting tutorials.